Hello, my name is Theresa. I'm an associate professor at Montana Tech, and this learning unit is part of Principles of Epidemiology, and it covers disease transmission and infectious disease. It goes along with our text, Chapter 2, so I hope you enjoy this learning unit. So as an outline, we're going to understand the mechanisms of disease transmission, relate disease transmission to person, place, and time, and start to be familiar with the epidemiological triad. And then at the end of this material, we'll describe what notifiable conditions are, and we'll start to think about the different surveillance systems that are in place to capture data on disease transmission or diseases that are taking place, both the prevalence and the incidence of them. So when we think about diseases, either the presence or the absence of, we should probably start with a definition of what is a disease. So the most basic definition would be the absence of health. But from the British Medical Journal, I'll read to you their definition of disease. The name of the sum of abnormal phenomena displayed by a group of living organisms in association with a set of characteristics by which they differ from the norm for their species in such a way as to place them at a biological disadvantage. So when we start to think about the presence or the absence of disease, we frame it in the same context that we do, in a sense, when we do our accident investigation. These questions of who, what, why, when, how, and where. Our who is our person or our host. Our what is our agent, the thing that's causing the disease. And our why are our risk factors or our environmental factors. When, of course, would be the time, and how is the mode of transmission, which might also be a reservoir, and where would be your place. So when we think about epidemiology, try to hold these concepts present in your mind. What are the interactions of the person, place, and time, as well as the why, the risk factors, and the how, the mode of transmission. So our first topic is the epidemiological triad and how it influences disease. And the picture here really doesn't have much significance, although when I was growing up in the 80s and AIDS was a growing epidemic of growing proportions, people were certainly afraid of the virus at first, quite misunderstood. Queensryche, a band that my then boyfriend, now husband, listened to, did a song called The Spreading of Disease. So that's why I have the picture there. So the epidemiology triad or triangle is how disease is influenced in a person. And that's through the interaction of personal characteristics or the human characteristics. We also call this the host. So some of those characteristics could be age, race, sex, your genetic profile, previous diseases that the individual has had, family background, marital status, occupation, some things that might be common to you when you start to think about the host or the human that gets the disease. This disease usually occurs or is promoted to some kind of exposure of an agent in an environment. So some of our environmental characteristics are where we live, whether that's rural or urban, what type of neighborhood we live in, what type of house we're in, the food, water that we eat, water we would drink, radiation, how where we live on our longitude and latitude, noise, maybe pollution, things that we think of as risk factors, these environmental risk factors. And then our agent is what we would kind of think of as the causing of the disease itself. Although the host and the environment play a big role, it's carried to the environment, grown in the environment, and imparted on the host by either a biological agent, a chemical agent, a physical agent, a nutritional agent that's very similar to a chemical agent, but some texts break that out separately. The traditional model of infectious disease is known as the epidemiological triad, and it is depicted by the triangle figure on the previous slide. The triad consists of an external agent, a host, and an environment in which host and agent are brought together, causing the disease to occur in the host. A vector is an organism which transmits infection by conveying the pathogen from one host to another without causing disease in itself, and it may be part of the infectious disease process. A classic example of a vector is the anthracese mosquito. As the mosquito ingests blood from an infected host, it picks up the parasite. The parasites are harmless to the mosquito. However, after being stored in the saliva glands of the mosquito and injected into the next human in which the mosquito feeds on, the parasite causes malaria in the infected human. Thus, the mosquito serves as a vector for malaria. Another familiar example of a vector is the ticks of the species Lxodex, Lexidus, which can be vectors for Lyme disease. The epidemiological triad can be applied to diseases that are not infectious. Consider a smoke-related disease. If smoking, or more specifically a carcinogen in the smoke of the cigarettes, causes a disease, those who manufacture, sell, and distribute the cigarettes are vectors, bringing the disease-causing agent to the susceptible host. If we diagram the epidemiological triad, our agent would be our cigarettes. Our environment may be clean indoor air policies or peer pressure, to smoke or not to smoke. The host would be the person who, of course, smokes the cigarettes, but may be influenced by genetic susceptibility, income, or resilience, as well as their occupation, because we know that sometimes there's that additive effect. And the vector, therein again, is the manufacturer or the distributor, the vendors of these potential carcinogens. So the host is the who, and I think this is a place where there's some confusion in epidemiology, because we use the term host as the person or animal that gets sick, so that's the host. We also use the word host to describe the animal carrier, an animal that got sick and was carrying the disease, as opposed to a vector, an animal or an insect that didn't get sick but was carrying the disease. So the host is an organism, usually animals or humans, which are exposed to and harbor diseases. The host can be the organism that gets sick as well as the animal carrier that may or may not get sick. Although the host may know that it has the disease, it could have outward signs. Other times you have a host that has no idea that it has the disease, and therefore we call that the carrier. So this host term can be somewhat confusing, but think of it as the host. The host is hosting not a wine and cheese party, but a disease of some form. The environment is the where. The environment is the favorable surroundings and conditions external to the host that cause or allow the disease to be transmitted. Some diseases live best in waters, others live in blood. Still, some, like E. coli, live in warm temperatures but are killed by high heat. Other environmental factors include season of the year. For example, the peak of the flu season is between November and March. So time is the central component in the triangle. Most infectious diseases have an incubation period, the time between when the host is infected and when the disease symptoms occur. Or time may be described as the duration of the illness or the amount of time a person can be sick before death and recovery. Time also describes the period from an infection threshold, so you see something in a population, to an epidemic or a pandemic. And so we use the term time to describe multiple things as well. So now we're going to move on. So we talked about the epidemiological triad, how it influences mostly infectious diseases, but we can talk about other diseases as well. But there's this natural progression of diseases, both how they occur in stages and then the difference between chronic diseases and communicable diseases. So this is a generic example of the way we would view a disease. Diseases are viewed in separate states. You have no disease, then some form of exposure to an agent. You may have an incubation period, which is preclinical. It means that you don't have any outward signs. This is where a screening process might work, as opposed to having signs, going to see a physician, and therefore, once you have those signs or those symptoms, you're infected with the disease. So, as you have the disease, you travel through, and it may be its virulence is what happens once you have the outward signs. Is it severe enough to kill somebody, or do you have some form of recovery? So when we think about the stages of disease progression, take the intervention out of the mix as you're thinking about the way this progresses at this point in time, so we could kind of keep this clear cut, and it's a little bit easier to define, because certainly at any point in time, exposure period, the infected period, where you have some form of incubation, sometimes not, the pathogenicity, the toxicity. Just because I'm infected with something doesn't necessarily mean that I get the disease. I could, have the flu virus inside of my body, but might not develop any signs and symptoms. Therefore, I'm infected, but I don't have any pathogenicity to show the signs. And then once I get it, how it resolves itself. So diseases are typically viewed as states, an adverse health condition that characterizes an individual over a period of time, some form of duration. The onset of the disease can be seen as an event which occurs at a certain point in time. Another representation of our timeline. There's a point in which the host is susceptible, there's an exposure, there'll be some subclinical pathological changes that don't show themselves as signs or symptoms, and then symptoms which would bring about some kind of clinical disease, and an individual hopefully is diagnosed, and then they move forward to either recovery, disability, or of course even death. So each stage can vary with the characteristics of the agent, the host, and the environment. And the first stage is where the individual is susceptible to the disease. And this is the simplest model, which begins with you're susceptible and then you have some form of exposure. And the second stage would be there's pathological changes in the body. These are subclinical, so they are not seen in an individual. And for infectious diseases, this is thought of as your incubation period, the period in which it's growing inside the body. You may or may not be contagious to other people. It depends on the disease. And that's what makes certain diseases so dangerous, where people are able to transmit the disease. They're infectious. They're able to transmit something to somebody else, although they have no signs and symptoms themselves, kind of like Typhoid Mary was. Our third stage is where you'll have pathological changes in the body that manifests itself as a disease. This is where you have the event, that mark in a point of time, some form of diagnosis, and then it ends with the resolution. So this is our communicable disease prototype. You see you have your subclinical stages, which are your incubation period and your biological onset, where now you can become infectious, and then your clinical onset is when you are still probably infectious, maybe not, but mostly, but you have the signs and the symptoms of it, so the disease has come out and can be identified. Sometimes screening processes can catch people at periods of time where they do have some biological onset, but they themselves don't have the signs and symptoms of the disease. And this is our prototype for a disease such as cancer, where instead of having your instead of having your exposure and your incubation period, we call this an induction period instead of an incubation period. But it still has the same layout of some form of exposure, biological onset or a latency period, a clinical onset, and then a resolution at the end. So I just wanted to show you kind of an example here to break up our progression of disease with a slightly different topic that looks at distance, right? So this is the incidence of leukemia following the atomic bomb explosion for survivors who are residents of the city Hiroshima. And you can see that both graphs, if you look at both graphs, they both have a peak. The bomb was dropped in 1945, and there's a peak onset right around 1951-52 of leukemia. But if we look at our axes here, our top axes, people were much closer to the bomb, right? They were less than 100 meters or between 100 meters and 200 meters away. And our annual incident rate goes from 0 to 320. And although it was the same time period, right, a different population, but the same event, because people were located further away, their place was distant, our annual incident rate went from 0 to only 30, as opposed to 0 to 320. So this distance factor can play a big role in the way diseases develop and the frequency for which the disease develops. So we say in public health, with a small typo there that I will fix, diagnosis is just the tip of the iceberg, because once you are diagnosed, if it is a disease that has an incubation period and a transmission period before the clinical stage, then we don't know how many people have been infected. Interparent infections are really important because they play a role in the transmission of infectious diseases. The spread of polio, meningitis, and other diseases can only be explained on this basis. The role of this latent infection period is important for certain types of viral diseases. The latent infection, the host does not shed the agent, which lies dormant in the host. A viral disease may occur early in life in one clinical form and later in life in another clinical form. We're probably all familiar with this, with having chickenpox when you were younger predisposes you to having shingles as you age.